Hi boys and girls, today we are going to be working on lesson 4 of topic 11 and we are on page 575. We are going to be modeling subtraction of fractions. So I'm going to go ahead and start with the video.
How can you use fraction strips to subtract fractions? Fraction strips help you see a picture of the problem.
Pictures really help me understand the problem.
A flower garden is divided into 8 equal sections.
Pictures really
If
help
4
me
sections are
understand the
used
problem.
to grow yellow roses, what fraction is left to grow other flowers? What operation can be used to find what fraction is left to grow other crops?
What operation can be used to find what fraction is left to grow other crops?
And if you notice on there, the clue
Take
word
away
is
a part
left.
from the
What
whole
fraction
to find
is
the difference.
left?
What will the numerators be in the equation?
Take away a part from the whole to find the difference. What will the numerators be in the equation?
The numerator for the whole is 8. The numerator for the part taken away is 4.
The numerator for
What
the
will
whole
the denominators
is 8.
be in this
the
equation?
numerator for the part taken away is 4. What will the denominators be in this equation?
Remember that
Both
the
denominators will
denominator
be
will
8
tell you
because the
how
garden
many
is divided
parts
into
are in
8
one
sections.
whole.
Use
Both
a model.
denominators will be
How
8
can you use
because
fraction
the garden
strips
is
to
divided
represent the
into 8
fraction for the
sections.
whole garden?
Use a model. How can you use fraction strips to represent the fraction for the whole garden?
So this is where the models are important. Remember that when we're
Use
talking
8
about
1/8
fractions,
fraction strips to
fractions
represent
come
the
from
whole
the
flower
whole.
garden. Take 4 strips away.
Use 8 1/8
What does the
fraction
phrase
strips to
"take
represent the
away"
whole flower
remind you
garden.
to do?
Take 4 strips away. What does the phrase "take away" remind you to do?
Remember, boys and girls, that we're cutting it into eighths because the denominator says 8. So we're cutting it into 8 equal parts. So in total, there's 8 equal parts, and they want me to take away. That
The phrase
word
"take away" reminds you to
remember, I hope
subtract.
it reminds you of subtraction.
Why do you need to take away 4
The
of
phrase
the 1/8
"take away"
strips?
reminds you to subtract. Why do you need to
Take away 4 of the 1/8 strips
strips
to find the fraction of the garden that can be used to grow other flowers.
Take away 4
Now
of the
that you have
1/8
taken away
strips
4
to find
strips,
the fraction of the garden
what fraction of the garden
that
can
can
be
be used
used
to grow
for
other
other
flowers?
flowers?
Now that you have taken away 4 strips, what
4 strips
fraction
are
of the garden
left,
can be used
so
for
4/8
other flowers?
of the garden is left to grow other flowers. How
4
should you
strips are
write the
left,
fractions to
so
find how much of
4/8
the
of
garden is left for
to
growing
grow
other flowers?
How should you write the fractions to find how much of the garden is left for growing
Subtract the
other
numerators.
flowers?
Write the part taken away over the like denominators. Write the
Subtract
difference
the
in
numerators.
simplest form.
Write the
Can we
part taken
simplify
away
4/8?
over the like denominators.
What is 4/8 in simplified
Write the
form?
difference in simplest form. Can we simplify 4/8? What is 4/8 in simplified form?
Remember that when we're talking about 4/8, 4 is half of 8.
Divide the numerator
so
and denominator by 4.
Into
4/8
1/2.
simplifies to 1/2.
Divide the numerator
So,
and
1/2 of
denominator
the
by
garden
4.
is left to grow other
4/8
flowers.
simplifies to 1/2.
Now you know how to use fraction
So,
strips to
1/2
subtract
of the garden
fractions.
is left to grow other flowers. Now you know how to use fraction strips to subtract fractions.
So let's go ahead and go into our book. We are going to go into page 577. And I'm going to start with question number 1 through 4. It says, in 1 through 4, use the fraction strips to subtract. Simplify if possible. So notice that there's a whole. And the whole, if we look at the denominator, should be broken apart into 3 equal parts. Right? Because the denominator says that there's 3, so that means that there's 3 equal parts. Now, how many would be shaded? In this case, there's going to be 2. That's why there's one right here, and then the other one was here. So that makes 2. They want me to subtract one of those. That's why you see the arrow taking it away. There was 2 of them, but then they're taking 1 away. So how many are left? How many pieces will be left? There's only going to be 1/3 left. Okay, number 2. So the same thing here. If you look at the denominator, there's 5. So there's 1 part, 2 parts, 3 parts, 4 parts, 5 parts. And they're all fifths. We have 3 of them. 1, and then 2 and 3. They want me to take away 2. That's why you see the arrow where we're taking away the 2. So how many are going to be left? There's only 1/5 left. Number 3, there's no more diagram on here, but we can go ahead and do this one because we've been practicing subtraction and addition of like denominators. Remember that the denominator will stay the same. So now we're going to do the numerator. 7 minus 3 will equal to 4. Number 4, we're going to leave the same denominator, stays the same. 7 minus 1 is 6. I'm going to go ahead and go into question number 5. It says, in the problem at the top of the previous page, suppose 2 other sections were used to grow peonies. 2 other sections were used to grow peonies. So I'm going to go over here. And then it said that 2 of them were for peonies. Peonies, peonies, 2 of them. What fraction of the garden is now available for other flowers? Remember, we go back over here. There was 1, 2, 3, 4. There was 4 parts that were being used. In total, there was 8. So now we're going to be using 2 more for the peonies. So I'm going to add the 2 that we're using. The denominator is 8 because there's only 8 parts. So how many parts are being used? The denominator stays the same. 4 plus 2 is 6. So how many parts are still available to use? Well, this one's not being used and this one is not being used. So how many parts are left? There are 2 parts out of 8 left that could be used to plant more flowers. Number 6. In exercise 3, explain how you simplified your answer on exercise 3. So exercise 3 is right here. My answer was 4/12. And they're asking us, how did we simplify our answer? And I did not simplify them because I don't want to confuse you. But I did show you in the last video from lesson number 3 how to simplify. So I'm going to go ahead and simplify it for you. So I'm going to go to another page. And my fraction is 4/12. So the way that we simplify it is we're going to, remember, take the number 4. And we're going to do our common multiples. Take the 12. And we're going to do the same thing. So we start with 1. 1 times what gives me 4? It's 1 times 4. How about 2? 2 times something? Yes, 2 times 2 gives me 4. Anything with 3? No. How about 4? Yes, but 4 is already there. 5? No. 6? No. So now we go to 12. So I know that 1 times 12 gives me 12. How about 2? 2 times 6 gives me 12. How about 3? 3 times 4. How about 5? No. 6? Yes, which will be the 6 times 2, but it's already there. So I'm going to look to see which one do they both have in common. Remember, we do not use 1. So I'm going to start. This one has a 2. Does the bottom have a 2? Yes. Notice that the top has a 4 and the bottom also has a 4. So whenever you have 2 numbers or more than 2 numbers that are the same, we always want to use the largest. In this case, it's going to be the 4. The 4 is larger than the 2, so we're going to divide by 4. So we're going to ask ourselves, 4 times what gives me 4? That would be 1. And then we do the bottom. 4 times what gives me 12? That would be 3. So my simplified fraction would be 1/3. It says, explain how you simplified your answer. This is the way that I'm explaining how to simplify the fraction. So now we're going into the independent practice, 7 through 20. It says use objects such as fraction strips to subtract, simplify if possible. So on the first one, there is 11 12ths. If you notice, there's 11. They're taking away 5. 1, 2, 3, 4, 5. How many will be left? 1, 2, 3, 4, 5, 6. So my difference is 6. The denominator stays the same. Remember, 6 is half of 12. So my simplified fraction would be half. We go to number 8. So we have 1 whole minus a half. So if I have 1 whole and I take away 1 part, what will be left? 1/2. Number 9, I am going to subtract, so the denominator stays the same. 4 minus 2 is 2. Denominator stays the same. 7 minus 5 is 2. Denominator stays the same. 9 minus 3, 6. Number 12, denominator stays the same. 4 minus 1 is 3. Remember, 3 is half of 6, so that would be 1/2. Denominator stays the same. 5 minus 2 is 3. Number 14, the denominator will stay the same. 7 minus 4 is 3. Number 15, denominator stays the same. 8 minus 2 is 6. Denominator will be staying the same, which will be 5. 3 minus 1 is 2. Number 17, the denominator stays the same. 5 minus 4 is 1. 18, denominator stays the same. 4 minus 4 is actually 0. So here, we're actually taking away 4/5 out of 4/5. So we're going to be left with nothing because we're taking away all of the parts. Denominator stays the same. 8 minus 4 is 4. And the last one, denominator stays the same. 1 minus 1 is 0. Remember, if we have 1/3 and we take away 1/3, we're going to be left with nothing. So now let's go ahead and continue to the back to problem number 21. What subtraction problem did Miles show using the fraction strip below? write the answer in simplest form. So I'm looking for a subtraction problem. So we're going to have to think, how many parts were there in all? 1, 2, 3, 4, 5, 6, 7. So there was 7/8. I'm going to take away. How many did he take away? 1, 2, 3. So how many are left? 1, 2, 3, and 4. Remember that 4 is half of 8, so it's going to be half. So now we're going to go into number 22. Using only odd numbers for numerators, write two different subtraction problems that have a difference of half. So they want us to use only odd numbers. So when I do odd, I think of Joel. So remember, odd is going to be odd and even. If you remember from second grade, even is start with 0, odd is 1, even is 2, odd is 3. Sorry. Even is 4, odd is 5, even is 6, odd is 7, even is 8, odd is 9. And 10, well, that's a number, it's no longer a digit. So we're looking for numerators that are going to be odd. And they want me to find two subtraction problems that have a difference of half. So two subtraction problems that have a difference of half. So if you notice, using odd numbers, we can use 3, 5, 7, 9, or 1. I'm going to use the big one, which is going to be 9. And I'm going to go ahead and subtract. I'm going to do 7. So 9 minus 7 is actually 2. So remember, in order for it to be half, the number at the bottom has to be doubled. So I could do, that wouldn't work. So I couldn't do 7. I could do 3. 9 minus 3, that would be 6. If we doubled 6, that would be 12. So for 12, 6, we know that is half of 12. And we were looking for it to have a difference of half. So those two would work. 9 twelfths minus 3 twelfths. Notice that I was playing around only with the odd numbers in order to get to half. Number 23. In Kayla's class, 2 9s of the students are wearing blue shirts. What fraction of the students are not wearing blue shirts? Show your work. So remember, there's 9 in total. 2 of them are wearing blue. How many are not? So how many students are there in all? There is 9 students in all. So that means the whole thing is 9 over 9. I'm going to subtract the 2 9s who are wearing the blue. How many are not? The denominator will remain the same. 9 minus 2 will be 7. So how many are not? 7 are not wearing blue. Number 24. An airplane flew 1,440 miles in 4 hours. How many miles did the plane fly each hour? Right away, each means to divide. So I'm going to take my whole and I'm going to divide it by 4 hours. So I'm going to go ahead and do the long division. 4 times what equals 1? Nothing. So I'm going to regroup. So I have 14. 4 times what gives me 14? 4 times 3 gives me 12. So now I'm going to subtract. 14 minus 12 is 2. So I'm going to bring down the 4. 4 times what gives me 24? 4 times 6 gives me 24. So if we subtract, that would be 0. So now I bring down the last digit. 4 times what gives me 0? 4 times nothing is 0. So my answer will be 360 miles every hour. Number 25. Audrey wrote a subtraction problem that has a difference of 1/3. Which problem did she write? Remember that the denominator stays the same. 2 minus 1 is 1. Denominator stays the same. 5 minus 4 is 1. Denominator stays the same. 5 minus 2 is 3. Denominator stays the same. 3 minus 1 is 2. Notice that none of those answers give me what I'm looking for. I was looking for 1/3. Why? Because remember, we can still simplify those fractions to make them smaller. Now, I'm going to eliminate A and B because if you notice, the numerator is 1. When the numerator is 1, you cannot make the fraction smaller. So right away, I'm going to eliminate those two. So I'm between 3/9 and 2/8. So I'm going to go ahead and bring my fractions to another page. And I have 3/9. And then the other one, was 2/8. I need to make these fractions smaller. So I'm going to start with 3/9. Remember, for 3, we're going to do our t-chart. For 9, we're going to do our t-chart and find the multiples of 3 and 9. For 3, we have 1 times 3, and that's basically it. Those are the only numbers I can multiply to give me 3. For 9, we have 1 times 9. 2, we cannot. 3, we have 3 times 3. And that's basically all the numbers that will equal to 9. So, what number do they both have in common? They have a 1. Remember, we do not use the 1 because if we divide by 1, we're going to get the same number. So, we're going to choose 3. So, we're going to divide by 3. And we're going to say 3 times what gives me 3? 3 times 1. 3 times what gives me 9? That is 3. So my new fraction is 1/3. I'm going to go ahead and do 2/8. So I'm going to do my t-chart for 2 and my t-chart for 8. We have 2 times 1, and that's basically it. We have 1 times 8, 2 times 4, 3 times nothing, 4, yes, 4 times 2, but it's already there. And that's basically it. Notice that they both have in common the 1, but we do not use the 1 because then the number will stay the same. So the next digit we can use would be the 2. So I'm going to divide by 2. So I'm going to ask myself, 2 times what gives me 2? That would be 1. 2 times what gives me 8? That would be 4. So my new fraction is 1/4. So my answer that has a difference of 1/3 is going to be letter C. Number 26. In problem 23, what number represents the whole class? How do you know what fraction to use to represent this number? So in problem 23, talking about this one, what number represents the whole class? So remember, 2 out of 9 had blue. I keep telling you guys that the denominator is going to tell me how many total parts. So in this problem, what number represents the whole class? The whole class is represented by the number 9. How do you know what fraction to use? Well, if I know that there's 9 students in all, my numerator has to be 9 because my whole class means 9. Remember that we show one whole by when the numerator and the denominator are the same. Number 27. Richard shared his bag of grapes with friends. He gave 2/10 of the bag to Melissa and 4/10 of the bag to Ryan. What fraction of the bag of the grapes does Richard have left? Right away, step number 1, look at the denominator, guys. My whole says that I'm going to have how many parts? 10. So I'm going to break it apart into 10 parts. There's 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, since I'm cutting it into tens, each one of these is 1/10. 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, and 1/10. It says that he gave 2/10 to Melissa. -1, -2, those were for Melly. 4 of those were given to Ryan. 1, 2, 3, 4. These are for Ryan. So what fraction is going to show how many grapes are left? How many are left? 1, 2, 3, 4. Denominator will be 10. So there's 4/10 of the grapes left. Number 28. Teresa gave away 8 baseball cards and has 4 baseball cards left. Write a subtraction problem to show the fraction of her baseball card Teresa has left. So Teresa gave away 8 and has 4 baseball cards, 8. So, left. So this is Teresa. She gave 8. And she still has 4 left. My question, how many cards did Teresa have in all? How many did she give? 8. How many does she have left? 4. How many, what's the total? 8 plus 4 is going to be 12. So that means my denominator is going to be 12. Okay, so how many cards does Teresa have left? So she had 12 cards in all. I'm going to take away the 8 cards that she gave away. How many are left? Denominator stays the same. 12 minus 8 is 4. You notice that my fraction is 4. That is the amount that she had left. But they wanted to see this part, the work. Boys and girls, now you're going to have your homework 11-4 so you can get to practice on the problems at the bottom and in the back. Please call me or send me a message if you have a question on any of these so I can help you. Remember that after this, you do have your topic 11 test for Friday. Notice that on your plan, I only gave you a certain number of questions. So you do not do them all. You're only going to do the ones that I wrote on the plan, which is 10 of them. Okay?